Okay, so continuing our videos on the topic of conic sections, let's have a look at the hyperbola. And in this video we're going to formulate the standard equation for the hyperbola. Now the hyperbola is defined as a complete set of points P in a plane such that the ratio of the distances from P to the fixed point F, called the focus, and from the point P to a fixed imaginary line, called the directrix, is a positive constant greater than 1. And that probably didn't mean anything to you. So let's have a look at what this means graphically. So here I have a hyperbola scribed out on some conical graph paper. So try not to go cross-eyed over this because it's what this graph paper is just two sets of concentric circles that are overlapping each other. And we'll use these overlaps later on. But the first thing to note is that the center of these concentric circles are the focal points, F and F prime. So just like the ellipse, the hyperbola is bifocal, and if we have two foci, we also have two directrices. So this cyan line I'll call D, and the one on the left, let's call this D prime. Now all that the definition is saying is that if we pick a point P on one of the branches of the hyperbola, the ratio of the distance from P to one of the focal points and from P to its nearest directrix, the perpendicular distance to the directrix that is, so this distance here is PF, and this distance PD, well the ratio PF on PD, which we call E for eccentricity, must be greater than 1. So basically this distance is longer than this distance. Now let's put all of this aside for the moment. The reason why I've overlaid this hyperbola over the two sets of concentric circles is to demonstrate that there are two geometric properties that we can take from this which will help us determine the standard equation for the hyperbola. For the first geometric property, let's consider the point P on one of the branches of the hyperbola, and for convenience I've chosen the point P to be at the intersection between two circles. Now the distance from point P to its nearest focus, as we can see here, is 3 units. We have 1 circle, 2 circle, and 3 circles to the center. So let's write that down. So the distance PF, here we have 3. The distance from point P to F prime, the further focus, is how many? 1, 2, 3, 4, 5, 6, 7, 8, 9 circles away, so it's 9 units away. So let's put the distance PF prime here. So we have 9 minus 3 is equal to 6. So the difference between the two distances is 6 units. Let's move this point further along to the next intersection of two circles. So here PF, the distance PF is 4 units. The distance PF prime is 10 units. And again the difference between these two, PF prime minus PF, is equal to 6 units. Moving the P along the curve again to the next intersection of two circles. So the distance PF is 5 units. The distance PF prime is 11 units, so the difference between these two is also 6 units. So can you see the pattern here is that the difference from one focus to a point on the hyperbola to the distance from the other focus to the same point on the hyperbola is a constant. In other words, PF prime minus PF is equal to a constant. And let's give this constant a value of 2a. Okay, so a here is a constant. So we say the difference between PF prime and PF is equal to 2a. For the second geometric property, let's consider the distance from focus to focus. And for convention, let's give the focus F the coordinates C0, so which means it lies on the x-axis at a distance c from the origin, and similarly f prime will have the distance negative c is 0 because it is symmetrical with f. So the distance f prime, focus to focus, is equal to 2c. And now note that we have a triangle here. So the triangle has the sides f prime, pf, and pf prime. And you may have learned previously about the triangle inequality, which simply states that the length of one side of the triangle, any side, is less than the lengths of the two other sides added together. So if we take the side length PF, so the length of one side of the triangle is less than the sum of the two other sides of the triangle. So this is by the triangle inequality. So now these are the two properties we will use to formulate the standard equation for the hyperbola. And now for my own convenience, and my apologies, I'm going to swap this inequality around a little bit. So I'll say that PF prime is less than PF plus FF prime. So the triangle inequality still works because PF prime is one side and the length of that side is still less than the sum of the two other sides. So now taking property number 2, we have PF prime is less than PF plus FF prime. If we rearrange this inequality a little bit by taking PF to the other side, we have PF prime minus PF is less than FF prime. FF we said was equal to 2c, and PF prime minus PF we said was equal to 2a. So we have 2a is less than 2c, and this implies then that a is less than c. So this is something that we need to take note of. Just scrolling up so we have a bit more clarity. The first property, PF prime minus PF, is equal to 2a. The distance PF prime we can calculate using the distance formula, which is equal to the square root of x minus c, so it's minus c all squared, plus y minus 0 all squared, minus 0 because the y coordinate of the focus is equal to 0. So that's equal to the distance PF prime. Now the distance PF, so we subtract the distance PF, which again by the distance formula is equal to x minus c all squared plus y minus 0 all squared, and this is equal to 2a. Alright, bear with me because we're going to be in for some tedious algebra. So rewriting this more neatly, we have x plus c, so double negative becomes a positive, plus y squared, and the square root of all of that, minus x minus c all squared plus y squared is equal to 2a. Let's take this to the other side. So we have the square root of x plus c all squared plus y squared is equal to 2a plus the square root of x minus c all squared plus y squared. We can get rid of this square root by squaring both sides. So if we square this side, we have to square the right hand side. And so the square root on the left hand side is gone. This term here in the parentheses can be expanded out. So we can write this as x squared plus 2cx plus c squared plus y squared, so the y squared gets copied down, is equal to, now if I square the right hand side, I will get 4a squared plus 4a times the square root of x minus c squared plus y squared. So it's the first term squared, then 2 times the first term times the second term, and then it's the second term squared. So here we have x minus c all squared plus y squared. Now similarly, this term can also be expanded out. We can write x minus c all squared as x squared minus 2cx plus c squared. Okay, so on the left hand side of the equation I have an x squared and I have an x squared on the right hand side, and these cancel out. Y squared on the left cancels the y squared on the right. C squared on the left cancels the c squared on the right. And let's take this negative 2cx to the other side. So now we have on the left hand side 4cx is equal to 4a squared plus 4a times the square root of x minus c all squared plus y squared. These 4's can cancel. And let's take this a squared to the other side. So we have cx minus a squared is equal to a times the square root of x minus c all squared plus y squared. Now to get rid of this square root on the right hand side, we have to square the right hand side. So we have to square the left hand side as well. Now the left hand side expands to c squared x squared, the first term squared, minus 2 times the first term times the second term. So we have 2 times a squared by cx plus the second term squared. So we have a to the fourth. On the right hand side, if we apply the square, we have a squared by x minus c all squared plus y squared. So we've gotten rid of the square root on the right hand side. Now this squared term expands again to x squared minus 2cx plus c squared. And multiplying the a squared in, I get a squared x squared minus 2a squared cx plus a squared c squared plus a squared y squared. Now these terms are common on the right and left and cancel. And let's move all of the x's and y's to the left hand side and move all the constants to the right hand side. So now we have on the left hand side c squared x squared minus a squared x squared minus a squared y squared equals a squared c squared minus a to the fourth. X squared is common, so x squared I can write outside of c squared minus a squared. The minus a squared y squared remains as it is. And a squared is common here, so I can write a squared outside of c squared minus a squared. And now let's divide both sides by a squared outside of c squared minus a squared. And this reduces us down to x squared on a squared minus y squared on c squared minus a squared, there should be a squared here, is equal to 1. And for convenience, we write x squared divided by a squared minus y squared divided by b squared is equal to 1. So where b squared is equal to c squared minus a squared. And due to the property a is less than c, b squared is always greater than 0. So thus we have derived the standard equation for the hyperbola. This property ensures that we don't divide by 0, and we'll discuss the reasons for this in the next video. So this video has introduced the hyperbola and we've formulated the standard equation. We will look at the features of the hyperbola in the next video. If you've learned something from watching this, please give me a thumbs up, and don't forget to subscribe for more videos that may help you with your homework and assignments. Best of luck with your studies, and I'll see you on the next video.